Woohoo! We are here with Math 40, doing a problem from 9.3, number 8, and this may be slightly different for different people, but I had a request for working all the way through the problem and then how to enter it in WebAssign. So this is the first part. The first part will be us actually working it out on the paper. And then the second part, which, spoilers, I've already recorded to make sure I was able to do it, I will connect as the second half. It will have something beautiful in the middle, I don't even know. And then it will go to a video of me actually showing you how to enter it into WebAssign. So let's get started. This problem is pretty bare bones with instructions. It gives you a quadratic equation you can see with the x squared, and it says use the quadratic formula. So I went ahead and made a little card that has the quadratic formula. This is such a key formula in math. I encourage you to have it memorized. It's something important to be able to refer to and to be able to write it out anytime you're taking a math class from now on, starting in algebra and kind of going all the way through calculus and beyond. It is a helpful formula. And just an aside, if you're struggling to get it memorized, there's a ton of videos on YouTube. You can go in, type in the quadratic formula song, and just about every high school in the country and some in other countries as well end up producing videos where people take popular songs and they sing the quadratic formula to it. So find a song, find a way to memorize it, but this is a really important formula to have memorized. So let's go ahead and get started with the problem. I'll have this card up here where you can't see it, and I'll bring it down when it's useful. But the first thing we need to do is we need to make sure that our quadratic equations, this is a quadratic equation, is in the right form. We got to make sure that this form is correct. So let's take a look. I've got 3x squared minus 6x minus 2 equals 0. The really important thing is that one side, pardon me, Sharktopus, has to have a 0. So you need this 0. So if you had a problem where there was stuff on both sides, you just have to move everything onto one side or the other, and you can choose. It will work regardless of which side you choose. Now, this is kind of nice that it's in this form. Let me show you the benefits. The first thing is the number in front of x squared is positive, which is going to make a lot of things easier. So the x squared, if you can aim for a positive coefficient, that's great. The next thing that we have is we have x squared and then x and then the constant. So they're in what's called descending order. So that's also going to be helpful because, and now let me bring back the card so we can take a look. We want this to be written out as in ax squared plus bx plus c equals 0. So ax squared plus bx plus c equals 0. Now, some of you who haven't had as much experience with this before are looking at this, I think, and saying, wait a minute, it doesn't have pluses in all those spots. I'm moving this so it's up there. There we go. It doesn't have pluses. And the pluses here just mean that whatever the sign is. So here, if you've got an A equals 3. Here, the plus B means that if I have a minus 6, it must be that B is negative 6. So whatever sign you have, that's what that letter is going to be equal to. That was me being a little awkward. Let me write it out so you can see more clearly. In this case, A equals 3, B equals negative 6, and C equals negative 2 in that order because they're in descending order. Now, if the terms were all switched around, would we just do one and then the next and then the next? No. A has to be the one that's next to x squared. B has to be the one that's next to x, and C has to be the constant, the one that doesn't have an x attached to it at all. That's very, very important. Okay, so now that I know what A, B, and C are, I can set up my x equals the opposite of b plus or minus radical b squared minus 4ac all over 2a. And as you're memorizing, think about the ways that help you memorize. So if it's helpful to say it out loud, say it out loud. Make it a song, make it a rhythm. If it's helpful for you to look at it, then make yourself a card or a bunch of them and put them up all over the house or all over the apartment where you can see them. If it helps you to go through and practice right before you go to bed or right after you wake up, depending on whether you learn best at night or first thing in the morning. That is the best way to tell your brain, hey brain, this is what's really important to me. And then your brain will say, oh, okay. And then it will try to remember that. If you've ever had a problem or been frustrated with something at night and then you wake up the next day and you're thinking, wow, I think I have an idea of how to solve that. The reason for that is that your brain does work on things. When you're sleeping, your brain is kind of sorting stuff out and putting stuff away. And if you tell it that this is important, it'll be something that your brain really does hold on to, make space for, focuses on. Okay, let's go ahead and actually, that was a very long-winded thing to say. Oops. Okay, I want the opposite of b. So whatever b is, I'm going to change the sign. So in this case, b is -6, so this is going to end up being a +6. Okay, plus or minus. Now inside, when I say b squared, it's the whole b. So the negative or the positive are included in the square. -4 times 3 times -2, a and c. And this is all over 2 times a, which in this case is 3. And you can see, given that a goes in the denominator, that's why I recommend if you can move all the terms, or if they start off this way so that the coefficient of x squared is positive, this is going to be a lot easier. Okay, let's go to the next step. I get the opposite of -6, so +6, plus or minus, radical. -6, the quantity squared is 36. Now notice here you've got a minus as well. So this is going to be a plus, and then 4 times 3 is 12, times 2 is 24. Or you could do this all on the calculator. I've got the calculator here ready in case I need it. And then I've got the whole thing over 2 times 3, which is 6. Okay, so I'm not going to be able to finish this on one page, but I can at least clean this up a little bit. 36 plus 24 is, you got it, 60. Hey, all over 6. Well, I could force it to, we just have a few more steps left, but to make it easier so that we're not squishing it all, I'm going to go ahead and go to another page. Pardon me, Sharktopus. Okay, so we're going to go to, and this is number 8, I think. 8, continued. If it's not 8, I'll change the number. Okay, so I've got 6 plus or minus radical 60 over 6. So let's go switch over to this. So first thing we need to know is we can't cancel these 6's even though they are winking, because this plus or minus, remember, plus always ruins the party. So anything fun you want to do, plus is going to be like, no, you can't do that. So always ruining the party. If there's a plus or a minus or both, don't cancel, even if they're like winking at each other, totally like begging you to, no, just say no. Just say, nope, not yet. We got to do this slowly. And then this 6, it's attached, it's actually part of 60, but it kind of wants to cancel too. Do not fall for that either. That's shenanigans. Don't fall for that. What we do need to do is we need to simplify, because I bet this square root or radical of 60 is, there's some stuff in there. So I'm just going to look at the radical or the square root first. And I'm going to say, let's see, I know this is 60, so that's 6 times 10. That's 2 times 3. That's 2 times 5. So let's see, I've got a 5 and a 3 and a 2 and a 2. Oh, look at that. I've got some twins. And do I have my square bear? Oh no, here's Square Bear. Here comes in Square Bear. Rah! If you haven't watched the bear math, you have no idea why I brought in a Square Bear here, but just rah, it's a very hungry bear. And all of these numbers are in a cabin, and these two twos that are twins go running. Ah, and then the Square Bear comes and eats one of them. Yum, 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 yum. And only one makes it out. So I end up with 2 and then radical 15. And why can't I simplify this any further? The answer is there are no twins in here. 5 and 3, the bear would not fall for it. The bear only falls for it if you've got identical twins here, then one of them can get out. So that's how that works. Okay, thank you, Square Bear. Okay, so this all is just a way to simplify that expression up there. So let me kind of put this over to the side, and then we get x equals 6 plus or minus radical 60 all over 6, which is 6 plus or minus 2 radical 15 all over 6. Now, you've got a couple of options. The way WebAssign solved this, the way we entered it, which is technically in the future when you're watching this, but I already made the video, so it's in the past for me. It's all like mind-blown stuff. I know, we're doing time travel here. It's pretty exciting. Sharktopus agrees too. Sharktopus is up for anything, you know, time travel, you know, eating, you know, a yacht. It's all, you know, this is your party guy right here. Okay, so there are two methods for simplifying. One would be to factor out a common factor. I could factor out a 2. Now, since WebAssign was actually looking for a slightly different form, let me show you a slightly different way to solve it, or to simplify it. There are multiple options, and they're good in different situations. So yeah, it's not a bad thing to know multiple ways to do this. One way to simplify this is, rather than trying to make this all make sense with a common factor, split this up into 2 fractions, by which I mean the 6 gets its own 6 and the 2 radical 15 gets its own 6. Now, if we do that, then life suddenly gets really easy, because this 6 and this 6 finally, oh my gosh, they've been winking for what feels like hours. They finally get to cancel. Oh, thank goodness. The cancel tension there was so high. Okay, and then I got a plus or a minus. And then over here, I can actually cancel. Now, I can't cancel completely, but I can cancel the 2 with the 6. And so I end up with woohoo! And here we are in WebAssign. Now this looks a little different from your WebAssign, because from the teacher's perspective, I can see the answers written right there. But that can be a little helpful for us, because now that we know what the answers are supposed to be, we can look here and see that WebAssign is expecting you to list them separately. You can list them in either order. I usually list the positive one first, the 1 plus first, because that's on top, but they're listing the negative one first because it is technically smaller. So it's going from smaller to larger. And that is something that you would see in mathematics. And someone had asked me, can you go through the steps of actually entering this? And unfortunately, you can't see my hands on the keyboard at the same time. But what you can see is that I can type in my 1 and my minus. I'm going to go ahead with the negative 1. I'm actually, yes, it is a negative number. So I'm going to go over here to the math pad, and I'm going to choose this symbol to give myself a fraction. And then on top of the fraction, I'm going to give myself a radical. Now, there are, I believe, other radicals if we go looking. So make sure that you don't accidentally get this one, which would be for radicals like cube root or fourth root. You want to go into the top level, the operations. That'll give you just the square root. That's the one we want. Okay, I'm going to type in the 15, and then in the denominator, I'm going to type in the 3. Now, make sure you use either your mouse or arrows or your trackpad. You need to, if you can see, let me move this a little bit, you need to move the cursor to the right. You need to move it out from under. So I use the right arrow, then just a comma from the keyboard, and we do the whole thing again, except this time I'm going to do 1 plus, and then again, I go into here and I grab my fraction symbol, my square root or just radical, and then radical 15, and then over 3. And then I could actually submit it. Now, recall that I said to use the fraction first. Let me show you. I'm going to go ahead and delete this. Let me show you what it would look like otherwise. If you reverse the order, if you go for the square root first, and then you make it a fraction, it will be incorrect. And you can kind of see the difference. You want the square root just on top over the 15, not including the entire fraction like it does here. So just double check, make sure that in fact, when you enter this, you've got the fraction, whatever we call it, button option first, and then the square root in the numerator. I'm going to put in the 15 and then the 3, and then I can't click submit. Submit for testing is something else entirely. So you just have to imagine that I submitted it and WebAssign says, yay, you got it, yay. So hopefully that made lots of sense and helped everyone figure out how to enter things. I encourage you to go looking. WebAssign is something that I use and a lot of instructors use. There are a lot of options here. There are a lot of things in here that we haven't studied, but you will study later on in Math 60. So, you could always just have a big old WebAssign party and you and your vaccinated friends can go through and see what shenanigans you can get up to using all of these options. This is, of course, trigonometry. This would be Math 95. And then Greek, this is something that we use a lot of in calculus and beyond, and also trigonometry. So again, woohoo, you guys are awesome. Math on.